Good morning, everyone. Last week we were talking about typing in sine, cosine, and tangent, and we introduced those three inverse trig functions. So there's actually six trig identities basically that we need to know. So today what we're going to talk about is how to actually use that to solve for sides on a triangle. So it's going to be a little bit of review, a little bit of new material. So our calculators can be useful in evaluating trig functions if we're given an angle. Use your calculator to evaluate the following trigonometric functions and then solve for the variable. Don't forget to keep in mind what mode we need to be in. So for example, for letter A, it says tangent of 24 degrees equals z over 34.627. So it's 24 degrees, so I need to make sure on my calculator I hit the mode button and I make sure that I am in degree mode. Otherwise, you're going to get very, very different answers. And I'm going to actually calculate tangent of 24 degrees. And I get this crazy long decimal. My recommendation is to use as much of that decimal as possible. So in my calculator, by the way, that's a 4. It looks like a 9 now. 522.86853. Okay, that's the crazy long decimal I get. So all that is equal to z over 34.627. So if we're solving for z, I need to multiply by 34.627, and I get that z is equal to 15 point yada yada yada. If you're not sure what to round to, one decimal place is usually okay for a side length, so I'm just going to go with 15.4. Okay, so if we look at this next one, it's cosine of pi over 6. That means I need to be in radian mode. So I'm going to go back into mode on my calculator, make sure I'm in radian mode, and type in cosine of pi divided by 6. And I get 0.866. Okay, big old decimal, right? Same idea. So if I'm trying to solve for y, I need to multiply both sides by 80. And if I round to one decimal place, I get 69.3. All right, last one, and this is the one that typically screws up students the most. Sine of 16 degrees, so that means I need to go back to degree mode. So yeah, there's going to be a lot of flipping back and forth. So sine of 16 degrees, and I get this crazy long decimal, right? Now here's the part that screws students up. A lot of students want to then multiply both sides by 14. But 14's on the top, you guys, so that's not going to work. So essentially what you have to imagine is you're multiplying both sides by x. So you're taking this big long decimal, multiplying it by x, and having it equal to 14. Then what you would do is divide both sides by the decimal, okay? So x is equal to 14 divided by that big long decimal, okay? And so then if I round, I would get that x is equal to 50.8. So in this one, just be careful, because when the variable is on the denominator, it tends to screw us up, that's all. So we can use this process to solve for missing sides in triangles, since we know that trig ratios are used to relate side lengths and angle measures. They can be used to help us find missing information about a right triangle when the Pythagorean theorem is not effective. So given the following triangle is a right triangle, okay, well if it is, then that's got to be the 90 degree right there. Why is Pythagorean's theorem not helpful in finding the value of x? Well, I only have one side. I know 8. Right? Pythagorean's theorem, you have to have 2 of the sides at least to be able to find the third one, so it's not going to work. So instead, using 23 degrees as the reference angle, what trig ratio should you use to set up and solve for x? So 23 is our reference angle, right? So the first thing we do is label our O, H, and A. H is the easiest one to label, the hypotenuse. O is the opposite side. A is the adjacent side. So I want to use O and H, so I'm thinking I want to use sine of 23 degrees is equal to O, which in this case is x, over H, which in this case is 8. So now, at letter C, we've already set it up, solve for that missing side. I need to double check, make sure I'm in degree mode, which I already am from our last question. So sine of 23 degrees, I get this crazy long decimal. I normally do not write all this out on my paper, you guys, because I know my next step is to multiply by 8. So I would just do that. But I want to make sure you're seeing where I'm getting these numbers so that you can also check and make sure that you're using the correct mode and that sort of thing, okay? So I get that that side length is about 3.1. All right, so here's what I want you guys to do. For each right triangle below, find the missing side n using right triangle trig. So sine, cosine, and tangent, okay? Even if you can use Pythagorean's theorem, I want to push you to use sine, cosine, and tangent just so you can get some practice with that. So at this point in time, pause the video, and when you're ready to see the answers, you can unpause it. All right, so you should be ready at this point. So here's our reference angle in this case. So I'm going to label my O, H, and A. And I want to solve for side n. So really, you could do one of two things. You could use sine and do sine of 53.18 degrees is equal to n over 5. Or you could also do tangent of 53.18 degrees equals opposite over adjacent. And if you don't believe me, we're going to solve both of them, and I'm going to show you that they both work. So sine of 53.18 degrees, I get this decimal, this 0.8005, multiply by 5, and I get that n is 4 when I round. And do the same thing with tangent. So tangent of 53.18, I get a decimal, it's 1.3357, so on and so forth. Multiply by 3, and I also get n is equal to 4. So basically what I'm doing here, you guys, is just kind of proving a point that especially if you are given two sides, you can set up a lot of different trig ratios. Technically, too, we could have also used Pythagorean's theorem because we had both sides 5 and 3, so we could get that third side. But remember, I want us to practice using right triangle trig, not Pythagorean's theorem. I know you guys can do that one, okay? All right, number 2. Couple different ways you could set it up using this 30 degrees. Here's H, O, and A. So you could either do cosine and use A and H, or you could use tangent and use O and A. For me personally, I'm going to choose cosine. But remember, if you use tangent, that's okay. You should get the same answer I do. So cosine is ka, so ka toa. So that's A, which is n in this case, over H, which is 8. So cosine of 30 degrees, my decimal I get is 0.8660, and so on. I'll multiply by 8 in my calculator, and I get that n is 6.9 when I round. Okay, if you used tangent equals, like tangent of 30 degrees equals 4 over n, you should get the same thing. So I'm going to do that really quick just in case you did choose that route. This is the one you have to be careful of, though, you guys, because you've got your decimal right here. And you're going to multiply both sides by n. So you're going to get that decimal n equals 4. So you have to do 4 divided by that decimal in that calculator to get n equals 6.9. Okay, so watch out for that. Remember, when the variable's on the bottom, that tends to be tricky. All right, last one. Again, a couple different ways you can do it. Here's our reference angle, 45 degrees. Here's our hypotenuse, our opposite side, adjacent. I'm going to go with sine and do sine of 45 degrees is equal to O, which in this case is 6, over H, which is n. So sine of 45 degrees, I get this crazy decimal. Remember, I want you to use as much of the decimal as you can, okay? Then we're going to multiply both sides by n and do 6 divided by this decimal. And I get n equals, when I round, 8.5. Okay, you could have also used cosine, and you should still be getting that same answer. All right, so here's the other kind of trick to this. What if you're given a trig function to solve for a side, but it's not sine, cosine, or tangent? Okay, couple things we need to remember which ones went with each other. So tangent went with cotangent. That's the easy one to remember. Tangent and cotangent go together. Here's the part that screws me up personally, is because we've got cosecant, secant, sine, and cosine. I always think that S goes with S and C goes with C. It is the exact opposite of that. So personally, it screws me up. So I just try to remember it's opposite, that sine goes with cosecant and cosine goes with secant. So it's almost like S goes with C, kind of. I know that's a little weird, but kind of helps me out. So here's my thought on this one. Remember how they were inverses of each other? Like if sine of 40 degrees is equal to 4 over 2, then cosecant of 40 degrees is equal to 2 over 4, okay? What you then have to do, let's say for this first one, for example, is the first thing you have to do is change cosecant to its inverse, which is sine of pi over 6. And instead of the y over 80 like we started with, you're going to have it equal to 80 over y. So you need to flip that ratio. Then everything else is exactly the same like the page we did before. I do need to make sure I'm in radian mode though now because we're looking at pi over 6. So sine of pi divided by 6, I get 0.5. Multiply both sides by y. So 80 divided by 0.5, I get that y is equal to 160. Okay, try these next two and pause the video real quick, and then we'll go over the answers when you're ready. You can just unpause. All right, so secant goes with cosine. So I can rewrite this as cosine of 45 degrees is equal to 12 over z, right? So I'm flip-flopping it. Need to go back into my mode, change back into degree. And I know that's a pain, but you got to make sure that you're switching back and forth. You're in the correct mode, okay? Equals 12 over z. So I get this decimal, z equals 12. So 12 divided by the decimal, and you should get z equals, it's actually 16.97. So if we stick to the rounding to one decimal place, it actually rounds all the way up to 17. So I'm going to stick with that rule just because I don't want to be inconsistent. All right, cotangent goes with tangent, so I can write tangent of 120 is equal to x over 4. So tangent of 120 degrees. And I got kind of a weird number, and I think I might know why. Oh, no, I'm in degree mode. Okay, so I'm good. I got kind of a weird decimal, and I wanted to make sure I was in the right mode. Then multiply both sides by 4, and I get x is equal to negative 6.9 if I round. Okay? All right, you guys. So there is homework number 3, and it's part 2 technically. You'll see me kind of doing that throughout the week, but don't worry. Don't make sure to, if you can print out the homework, awesome. If you want to just do it on a blank sheet of paper, that's okay too. Take a picture and make sure to post it under the assignment on Google Classroom. That's what I'm going to be grading. Okay. And then if you have any questions, as always, feel free to stop in for office hours.